Hello students, in this video we will discuss enthalpy, change in enthalpy during the isobaric process and enthalpy in the porous plug experiment or in Joule-Thomson effect. Very important topics for BSc Part 1 physics courses as well as for BSc Part 1 chemistry courses in thermodynamics and in thermochemistry. First of all, we have to define enthalpy. Enthalpy is an extensive thermodynamical variable or an extensive thermodynamical property which is denoted by the symbol capital H. Mathematically, enthalpy can be defined as the sum of internal energy capital U and product of pressure capital P and volume say capital V of a system, that is a gas. So enthalpy capital H equals to capital U, that is internal energy of the system, plus product of pressure multiplied by volume V, that is H is equal to enthalpy of a system or a gas. Capital H is equal to internal energy U plus pressure of the system, pressure of the gas multiplied by volume of the gas, that is H is equal to U plus PV. Suppose it is equation number 1 and it is the mathematical definition of enthalpy. Now we have to show that enthalpy during the isobaric process, that is change in enthalpy during the isobaric process HF minus HI is equal to heat transferred or available energy. So write down change in enthalpy during the isobaric process. Isobaric process is the process in which pressure remains constant. आइसोबारिक प्रोसेस वह प्रोसेस है जिसमें सिस्टम का गैस का प्रेशर कांस्टेंट होता है. आइसोबारिक प्रोसेस मीन्स प्रेशर ऑफ द सिस्टम रिमेन्स कांस्टेंट, P is equal to constant. Now differentiating equation 1 both sides, we have in LHS exact differentiation of enthalpy H is dH, differentiating on differentiation, that is differentiating both sides of equation 1 on differentiation, we have exact differentiation of enthalpy H is dH equals to differentiation of internal energy U is du, that is change in internal energy, plus differentiation, now differentiation of pressure, product of two variables pressure and volume is P into dV plus V into dP, taking pressure and volume constant 1 by 1 and volume and pressure variable. If pressure is taken constant, then volume is variable, so it is P into dV, and when volume is constant, then pressure is variable, so it is V into dP. So differentiation of P dV is P into dV plus V into dP, and we know from the first law of thermodynamics du plus P dV, that is a change in internal energy or increase in internal energy of the system, which is denoted by the symbol du, plus product of pressure multiplied by increase in volume, is equal to dq, that is heat supplied to the system. So in place of du plus pdv, we can write dq plus second term is now the term du plus pdv. In place of du plus pdv, we have written dq using the first law of thermodynamics, and the remaining term, that is last term, is v plus dp. So it is dq in place of du plus pdv plus v into dp. Let it is equation number 2. We know that in the isobaric process, pressure remains constant. So in the isobaric process, since pressure remains constant, therefore change in pressure, that is dp is equal to 0. So putting dp is equal to 0 in equation 2, we have equation 2 reduces to LHS is change in enthalpy dH. So dH equals to dq. In place of dH, we can write HF, that is final enthalpy. HF, capital H, suffix में HF है, F for final, H is the symbol of enthalpy. So HF is HF minus HI. HI is the initial enthalpy. So change in enthalpy dH is equal to HF minus HI, and it is equal to dq, that is dq is the heat transfer or energy available. So it is clear that change in enthalpy in the isobaric process, that is HF minus HI, is equal to heat transfer dq, is equal to dq, which is heat transferred or available energy. Heat transferred or available energy. Now in last, we have to discuss enthalpy in porous plug experiment, or in Joule-Thomson effect, or in the throttling process. Joule-Thomson effect is also known as throttling process. Joule-Thomson effect is when a gas is allowed to pass through a porous, insulated porous plug, keeping pressure difference on both sides of the porous plug. Then after passing the gas through the porous plug, temperature of the system gas falls, that is decreased, and it is known as Joule-Thomson effect or throttling process or the porous plug experiment. तो हम लोगों ने जूल-थॉम्सन इफेक्ट को डिफाइन किया कि जब किसी गैस को किसी इंसुलेटेड पोरस प्लग से होकर पास कराया जाता है, प्रेशर डिफरेंस रखकर, पोरस प्लग के लेफ्ट साइड में हाई प्रेशर एंड पोरस प्लग के राइट साइड में लो प्रेशर. Therefore, a pressure difference is established across both sides of the porous plug, and then the gas is allowed to pass through the porous plug. Then after passing the porous plug, the temperature of the gas falls, that is temperature of the gas decreases, and this phenomenon is known as Joule-Thomson effect or the throttling process or the porous plug experiment. At ordinary temperature, almost all gases except hydrogen and helium show cooling effect, that is their temperature falls down after passing through the porous plug, except hydrogen and helium. Whereas hydrogen and helium show heating effect after passing through the porous plug. पोरस प्लग को पार करने के बाद मोस्टली गैसेस हाइड्रोजन एंड हीलियम को छोड़कर कूलिंग इफेक्ट को डिमोन्स्ट्रेट करते हैं, उनका टेम्परेचर घट जाता है ऑलमोस्ट ऑल गैसेस का एट ऑर्डिनरी टेम्परेचर जब पोरस प्लग से गैसेस को पार कराया जाता है। लेकिन हाइड्रोजन एंड हीलियम एक्सेप्शन है। हाइड्रोजन एंड हीलियम गैस को जब इंसुलेटेड पोरस प्लग से पास कराया जाता है प्रेशर डिफरेंस रखकर, प्रेशर डिफरेंस अप्लाई कर, तो हाइड्रोजन एंड हीलियम का टेम्परेचर बढ़ जाता है पोरस प्लग से पार करने के बाद। दैट मीन्स हाइड्रोजन एंड हीलियम शो हीटिंग इफेक्ट instead of cooling, which were observed in most of the gases at the ordinary temperature except hydrogen and helium. So in Joule-Thomson effect, change in temperature when the gas is passed through the porous plug is directly proportional to the pressure difference of two sides of the porous plug. And the relation between pressure difference and temperature, change in temperature, we will discuss, we will derive the expression for it in the next video of the thermodynamics. Now we have to discuss the effect of effect on the enthalpy of a gas in Joule-Thomson effect or in the porous plug experiment. So write down enthalpy in the porous plug experiment or in Joule-Thomson effect, or in Joule-Thomson effect, that is JT effect. Let Pi and Vi are the pressure and volume of a gas initially, that is before passing the porous plug, while Pf and Vf are the final pressure and final volume of the gas after passing the porous plug. So net work done by the gas is equal to net work done by the gas, that is by the system, when the gas will pass through the porous plug, net work done by the gas is W equals to Pf Vf, that is product of final pressure and volume, minus Pi Vi, that is product of initial pressure and initial volume. We can also write it as W is equal to P2 V2 minus P1 V1 when initial pressure and final pressure are taken as P1 and P2 respectively, while initial volume and final volume of the gas are taken as V1 and V2 respectively. Then net work done by the gas in this process in Joule-Thomson effect or in the porous plug experiment is W is equal to, we can write in that case W is equal to P2 V2 minus P1 V1. Suppose this is equation number 1 of this topic. As there is no exchange of heat between the system and surroundings in the porous plug experiment, so dq is equal to 0. That is amount of heat, there is no transfer of heat between system and surroundings. So dq is equal to amount of heat which is transferred, dq is equal to 0. Therefore, this work done, W is equal to Pf Vf minus Pi Vi, comes from the internal energy of the system, internal energy of the gas. So, using the first law of thermodynamics, since dq is equal to 0, therefore dq is equal to 0, therefore dw is equal to minus du. That is, work done by the system is equal to decrease in internal energy of the system. क्योंकि यहाँ जो वर्क डन होगा वह इंटरनल एनर्जी के ही के द्वारा होगा, क्योंकि हीट का एक्सचेंज जूल थॉम्सन इफेक्ट में और पोरस प्लग एक्सपेरिमेंट में सिस्टम का सराउंडिंग के साथ हीट का एक्सचेंज नहीं होता है. देयरफॉर इन द फर्स्ट लॉ ऑफ थर्मोडायनामिक्स dq, amount of heat transferred is 0, dq is equal to 0, therefore 0 is equal to du plus dw. Therefore, work done by the system, work done by the gas, dw is equal to minus du, that is, there will be decrease in the internal energy. So, using the first law of thermodynamics, we can write work done by the system, w is equal to Pf Vf minus Pi Vi as decrease in internal energy, that is U1 minus U2. So, which is the change in internal energy, decrease in internal energy. So, we have U1, Ui is the initial internal energy of the system when the gas is not passed through the porous plug, and UF is the final internal energy of the system gas when the gas is passed through the porous plug. So, it is Ui minus UF. There is decrease in internal energy of the system, and at this cost, this decrease in internal energy of the system, it is utilized in work done by the system. So, Ui minus Uf is equal to Pf Vf minus Pi Vi, that is work done by the system. Now we can write Ui, capital Ui, that is initial internal energy of the system, plus Pi Vi, product of initial pressure Pi and Vi. It is taken to the LHS. So, negative term Pi Vi in the RHS becomes positive in after taking it to the LHS. So, it is Ui plus Pi Vi equals to Uf. Now, Uf is negative. Before Uf it is minus sign, and it is taken into RHS, so it will become positive. So, it will equal to capital Uf plus Pf Vf, which is present in RHS. So, it is Ui plus Pi Vi equals to Uf plus Pf Vf. That is, Ui plus Pi Vi is what? Initial enthalpy. Initial enthalpy, it is Hi, initial enthalpy, and Uf plus Pf is what? Final enthalpy. That is, Hi equal to is equal to Hf. That is, in general, we can write it as the quantity U plus PV. The quantity U plus PV is what? Enthalpy of the system. That is capital H, and it is constant. It remains constant during. It remains constant in the porous plug experiment or Joule-Thomson effect. Say it is equation number Hi is equal to Hf. It is equation number 2. Say it is equation 2, and that means we can write U plus Vb, the quantity U plus Vb, which is H, enthalpy H remains constant. It is constant. H equals to constant during the porous plug experiment or in Joule-Thomson effect or in the throttling process. This is, say it is equation number 3. Thus, it is clear that enthalpy in the porous plug experiment, enthalpy of the system, that is enthalpy of the gas in porous plug experiment, remains constant. Now this video is completed, in which we have discussed very important topics: enthalpy, change in enthalpy during the isobaric process, and enthalpy in the porous plug experiment or Joule-Thomson effect for BSc Part 1 physics courses. as well as for BSc Part 1 chemistry courses in thermodynamics and in thermochemistry. Thanks all of you for watching my YouTube channel Physics Quantum Classes.